All right, so what we're going to do now is looking at some word problems. Some of these are going to be law of sines, law of cosines. Some are just going to be basic right angles. So we have to remember all of that. So remember, you have to have a right angle. Also, to use your trig functions, remember, so you would have to have a right angle. And if you don't, then you can remember you can use law of sines. If you don't have a right angle. So, you could say sine of angle C over side C, sine of angle A over side A, which is also sine of angle B over side B. So all of those are equal to each other. So you would have to know an angle with the side opposite of it to be able to do this, or you can know an angle, and then the side opposite of it, okay, to be able to solve here. So that's law of sines. Remember, a law of cosines usually is if you know all of your sides, that's helpful, or if you know a side, angle, and a side. Okay, so it would be, let's say I know side, angle, side, so it would be a squared is going to be equal to b squared plus a c squared minus 2bc cosine of angle A. And then that formula stays true throughout. Okay. Remember, if you have a right triangle, though, if you have a right triangle, let's label it like that so we can see the difference here. If we have a right triangle, then we can use our regular trig functions. So let's look at angle A up here. Let's just say I know angle A. So we could say sine of angle A is going to be the opposite over your hypotenuse. Cosine of angle A is going to be your adjacent over your hypotenuse. And then tangent of angle A is your opposite over your adjacent side. Okay. So remember, those ratios change with what angle you are looking at. We don't do our trig functions, our right angle trig functions with that angle C there. Okay, so we've got our law of sines, we've got our law of cosines, and then we've just got our right triangles here. Okay, so let's look at these questions now. So it says for triangle ABC, angle A is 43 degrees, side B is 3, and side A is 5. So we're assuming that this is not a right triangle because it doesn't say it. If it's a right triangle, it's going to say for right triangle ABC. So it will tell you. All right, so let's just draw us a little triangle. So angle A is going to be 43 degrees. Side B is going to be 3, and side A is going to be 5. So remember, it's always across like this. So if I wanted to find the measure of angle B, what could I use? Law of sines or law of cosines here? So for this one, I'm going to use law of sines. So I could say sine of angle A, which is 43 degrees, over side A, which is 5, is going to be equal to sine of angle B over 3. So this is where you can use your calculators. So you will be able to use your calculator in portions of the test here. So you'll say 3 times sine of 43 degrees divided by 5. And make sure your calculator is in degree mode. I am. Okay. And then you'll take second sine of that answer. So angle B is going to be 24.2 degrees. Okay. So what is the measure of angle C? So what would I do here? I would say 180 minus 43 minus a 24. So it would be 113 degrees. Okay, what is the length of side C here? So the length of side C, so you could say sine of 40 degrees over 5 is going to be equal to sine of 113 over side C. So for this one, you'll have C is going to be equal to 5 times sine of 113 over sine of 43. So it'll be what, 6.7? 6.8? Let's call it 6.8. Okay. Good deal. Alright, so let's look at this one. So this one says for triangle ABC, let A be equal to 7, B be equal to 6. Oh, hold on. Let me come back to this one while I'm thinking about it. Remember law of sines, we always have to check for our second angle. I didn't do that there, I'm sorry. So remember it only gives us our first quadrant, so I would do 180 minus 24 there. So remember, check for second possible triangle. Sorry. So if I said 180 minus this value, it's going to give me 156 degrees. 156 minus 43. Minus 180, it's not going to happen. So you can't have a 43 degree triangle, 156 degree triangle. So 156 plus 43 is 199, right? These two angles equal 199 degrees, and that's not possible. So you're not going to have a second triangle there. So don't forget that law of sines only gives you that one angle in one triangle. Okay? All right, so now, gotta remember that. So here, for triangle ABC, let side A be 7, side B be 6, side C be 8. What is the measure of the largest angle? So to find that, the largest angle is going to be across from the largest side. Smallest angle is going to be across from the smallest side. So if I had A, B, C here, so side A is going to be 7, side B is going to be 6, and side C is going to be 8. So my largest side is going to be 8, so my largest angle is going to be angle C. So I need to find the measure of angle C. So to find the measure of angle C, I am going to use law of cosines. So I'm going to say 8 squared is going to be equal to 6 squared plus 7 squared minus 2 times 6 times 7 times cosine of angle C. Okay, so if you rearrange this, it's going to be 8 squared minus 6 squared minus 7 squared all over negative 2 times 6 times 7 is going to be equal to cosine of C. So I'll have 8 squared minus 6 squared minus 7 squared divided by a negative 2 times 6 times 7. And then I'm going to take the cosine of that angle. So that's going to be 75.5. And I'm going to round that to 76 degrees. Okay. So the smallest angle is going to be across from the smallest side. So angle B is going to be my smallest angle. So law of cosines tell me that it's going to be 6 squared is going to be equal to the sides on either side of that angle, 8 squared plus 7 squared minus 2 times 8 times 7 times cosine of angle B. So we'll have 6 squared minus 8 squared minus 7 squared. And then we would divide everything by that -2 times 8 times 7. And then once we do that, then we'll take the inverse cosine of that ratio there. So 6 squared minus 8 squared minus 7 squared divided by -2 times 8 times 7. And then second cosine of that answer. So angle B is going to be 46.6, so 47 degrees. Okay, so law of sines, law of cosines. Remember that was a big issue on test 1, so make sure that you go back and look through all this. All right. So let's look at number 3 here. So it says the angle of elevation to the top of a building changes from 20 degrees to 40 degrees as an observer advances 75 feet towards the building. Find the height of the building to the nearest foot. Okay, so here's my building. Draw a picture. So here's my building. An observer, let's say he's right here. The angle of elevation of that observer is 20 degrees. As I move forward 75 feet, okay, and I look up to the top of that building, the angle of elevation there is going to be 40 degrees. Okay, so I want to know how tall the building is. So how tall is this building? All right. Well, this is a right angle, right? Because the building is making a perpendicular with the ground. So if this is 40 degrees, this angle over here is 180 minus 40, which is going to be 140 degrees, right? So 140, 20, so this one's going to be 20 degrees up here. 40, 90, so this is going to be 50 degrees. So just, you can fill in kind of some information that you know. Okay. Well, if I were to look here, I could look at this triangle, and this is an obtuse triangle here. So I could use law of sines here to find, I could find this side, which I don't really need this side, right? Because what I'm looking for is the height, or I could find this side, right? So I could say sine of 20 degrees over 75 is going to be equal to sine of 140 over some y value. So this would be sine of 140, or 75, times sine of 140 divided by sine of 20. So that's going to be 140.95. We are in feet here. Okay, so then I could say, use this angle here. And if I'm looking at the big triangle here, I could say opposite over hypotenuse, so it'd be sine. So sine of 20 is going to be equal to x over 140.95. So it's going to be 48.2. And it said to the nearest foot, so it's going to be 48 feet. there's different ways to go about this one as well. You could have found this side here and then use this triangle to find it. Okay, so however you want to go through it and work through it. All right, let's look here. So in order to find the distance between 2 points A and B at opposite ends of the lake, a surveyor laid off a baseline BC at a right angle, so this is at a right angle to AB, and this baseline BC is equal to 150 feet. Using a transit, he found the angle BCA, so BCA is equal to 43 degrees. So this angle up here is 43 degrees. Find the distance AB. So I want to find this distance over here. So what is that? Just a right triangle, right? So I know this angle. I know, or I want to find the side that is opposite. The hypotenuse here would be this one up here. Sorry, you can't see that. The hypotenuse would be this side here. So I don't care about that one. So I want to find the side opposite of the angle, and I know the side that's adjacent. So opposite over adjacent is tangent. So tangent of 43 degrees is going to be equal to x over 150 feet. So we'll say 150 times tangent of 43, which is going to be 139.9 feet. And you can leave it just like that. Good up. All right. So let's look at this one. It says 2 sailboats leave a harbor in the Bahamas at the same time. The first sails at 23 miles per hour on a bearing of south 60 degrees east. So let's draw our north, south, east, and west. So remember, this is at a bearing of south. So we're going in the south direction, and from the south we're going to the east. So this is going to be 60 degrees at 23 miles per hour. So we're going 23 miles per hour in this direction. Okay. The second sails at 30 miles per hour in a direction of south 60 degrees west. So I'm going south 60 degrees. So from here it's going to be 60 degrees this way. And I'm going to be going at 30 miles per hour in this direction. Okay. Assuming that both boats maintain speed and heading after 2 hours, how far apart are the boats? So here's my boat. Let's call it boat A, or this one should be A. Boat A, and this is boat B. So I want to find the distance between the two boats. Let's call this X. That's what I'm looking for, that distance. After 2 hours. So what do I need to find here? So I need to find the miles that they are going in 2 hours. So 30 miles per hour times 2 hours is going to be 60 miles. So this distance here is going to be now, instead of, that's my miles per hour, so I'm going to erase that. So this is going to be 60 miles, right? Because 2 times 30 is 60 miles. So 2 times 23 is going to be what? 46 miles. So we're going 46 miles this way. Okay. So, and I know this is 60 degrees and this is 60 degrees. So that's a total of 120 degrees. So I know a side angle and a side. So I can find my x. So my x is going to be an x squared is going to be equal to the included angle, right, and the two sides that I know. So it's going to be 60 squared plus 46 squared. So law of cosines times 60 times 46 times cosine of 120 degrees. So 60 squared plus a 46 squared minus a 2 times 60 times 46 times cosine of 120. So that's 8476. And then I'm going to take the square root of that value. So x is going to be 92 miles. So they're going to be 92.1 miles apart. Good deal? All right. So that is word problems using law of sines, law of cosines, and then just your regular trig function. So if you have any questions about that, let me know. Y'all have a good day.